Yes, Assalamualaikum and good morning. Good morning, good day lah, whatever when you view this one. Okay, now we continue new topic for embedded system BEA 2374, which is serial communication, I squared C. Okay, at the end of the chapter, we will learn and understand what is the I squared C basic configuration and addressing, and then how to send or request the data, send or request data to or from I squared C devices. Send to request from. Okay, what is I squared C? I squared C, it represents integrated circuit, IIC. If pronounced as I squared C, it is a multi-master, multi-slave, single-ended serial computer bus and invented by Philips Semiconductor, which is now known as NSP at Senawang, I think. It is typically used for attaching lower speed peripheral ICs to processor and microcontroller. So, alternatively, I squared C, also known, some user call it I2C, and some pronounce it as IIC. But whatever it is, when serial communication, we name it as I squared C. Okay, now we go to the physical I squared C bus. It consists of two pins, SCL and SDA, serial clock line and serial data. Why serial? Okay. Before that, let me roughly view what is I squared C serial communication is. Let's say you have one Arduino. Sorry about my typing. And then you only have 13 digital pin, digital input output. And then your system require more than this 13 digital. So you need to add another Arduino, let's say. So in order to complete your system, you need two Arduino Uno. How to communicate each other? You can program both ways. You can program Arduino A and then this one Arduino B. You can program all together. But let's say the input come from A and then the output you want to do at output. How to communicate? This serial communication is the way. That's why when you see here, you must have serial clock line and serial data. Clock line means, you know, clock, I think we covered in chapter 1 if I'm not mistaken. It comes from the crystal. Lab 1 also I mentioned about it. So when you have the crystal, the timing, so these two microcontroller must have the same signal, clock signal. From this clock, then it can run synchronous lah. Else it's not run synchronous, so you cannot communicate each other. And then you have serial data. That means this data from A and B must be serial. Data from A can be run at B, and then data B can be run from A and so on lah. That's why we call it serial data. Serial data to transfer data and clock line to synchronize all data transfer from I squared C bus. There needs to be third wire, which is just the ground or 0 volt. So you must sharing the same ground. This one is very common lah. When you do all electronics, the grounding must be similar. That's why when you have analog input, when you do the hardware, but unluckily this semester you don't do the hardware PBL. If you do the hardware, you know, if you're not sharing the same device, same ground, that means you not have the same voltage supply. Without the same voltage supply, then your Arduino cannot measure the analog input from the sensor, from the analog input, because it is not sharing the same ground. Similar goes if you try doing the simulation. I think it makes sense lah for this. But after all, so this is the require of the third wire, which is ground. You must sharing the same ground or 0 volt. For the line to be able to transmit at high signal, we must provide pull-up resistor to 5V supply. You must have pull-up resistor. Later on, I think pull-up resistor cover in device, electronic device. I think you cover about it already. So this is how pull-up resistor are. So that whenever you run, you will have solid 5V to your I2C device. That happen here ni. You have I2C, device 1, device 2 and device 3. So pull-up resistor value usually 1.8 to 10 kilo ohm. The common value is 100. This one you can measure lah. What is the natural value? If the resistor are not present, the SCR/SDA line will always be low. Always be low. So you must have this one actually. Pull-up resistor. Actually the circuit, if I'm not mistaken, it's come from drawing here lah. I think in the switching part, switching lab is already covered. How the pull-up resistor required. Okay, next. This is the configuration. Each I2C connection must consist of master and slave. So master is what? Yalah, whatever you must, master tu macam boss lah. Slave ni hamba. Master means only one master in I2C. In one kapal, you cannot have two nakhoda. So that's why only one master, you must only have one master in I2C bus. And then it drive the serial clock line. So usually slave will follow whatever master punya clock. Okay, and then it initiate data transfer over the bus. It control all the data transfer process, and then it requests data from slave. The master, boss, is asking the data from the slave. What is the function of the slave? Slave ni hamba, ikut je arahan. So it's only transmit data when master request the data. If master not request, then don't do anything. Makan gaji buta lah orang kata. Okay, it can exist multiple slave. Okay, one master you may have more than one slave. It's not only one slave. Alright. How fast? Okay, this is important. For standard mode, the frequency is 100 kHz. Very fast, huh? The frequency is 100 kHz, so you can measure the clock. How fast the clock is. 1 divided by 100k, you got around 0.01 micro. No, 0.01, which is around 1 microsecond, if I'm not mistaken, or 0.1 microsecond, whatever. And then for the fast mode, it can go more than around 400 kHz, more faster. And then if you run it's on the high speed mode, it can go up to 3.4 MHz. Okay, let's calculate. The clock cycle for 3.4 MHz. Wait. You got around what? 3 nano? If I'm not mistaken. 3 or whatever lah. So you can calculate lah by your own. 1 divided by 1, 2. You can get around 2.929 microsecond. Very fast, eh? Okay, so this is how the addressing mode is. I2C device addressing, all I2C address are either 7 bits or 10 bits. It depends on the device addressing. Most of the modules are common chip used will have 7-bit addresses. For 7-bit address, we can have 128 devices on a single I2C bus. So you can have 128 devices. What project you want to do by using only Arduino 128 devices. So you can